Hello everyone, welcome to the Flying Machine channel. As we know, landing an aircraft is a crucial process and requires extreme caution. While most modern aircraft brakes are sufficient for landing under normal conditions, when the runway is covered by water or snow, additional methods are needed to stop the aircraft and reduce its landing distance. An effective way to reduce the landing distance is to activate the reverse thrust system on the aircraft's engines. What is reverse thrust, and how does it work? This is what we will discuss in this video. However, before we continue, please support the Flying Machines channel by subscribing and turning on the notification bell. Reverse thrust is a system in an aircraft engine that generates back thrust to slow the aircraft and reduce the braking distance during landing. Reverse thrust technology is very effective when aircraft are landing on limited runways or runways in extreme conditions, such as flooded runways, snowy runways, and sandy runways. Reverse thrust technology is widely used in turbine-powered aircraft, such as turbojets, turbofans, and turboprops. The device responsible for generating reverse thrust, or changing the direction of engine airflow, is called a thrust reverser. In turbojet or turbofan aircraft, the thrust reverser is located on the engine sump or cowling. A thrust reverser on a turbojet or turbofan engine can only reverse the airflow approximately 135 degrees toward the front of the aircraft, or in other words, only deflects the airflow sideways. Therefore, its use only provides a net efficiency of approximately 50% of the total deflected flow. There are two types of thrust reversers commonly used on turbojet or turbofan engines: the target reverser or Cascade reverser. The first is the target reverser or clamshell reverser. The target reverser or clamshell reverser is a simple reverser consisting of two shells located at the rear of the aircraft engine. When the reversers are activated, the shells open, enclosing the entire engine-generated airflow and deflecting it forward. This type of reverser can be found on small aircraft using turbojet or low-bypass turbofan engines, such as the Panavia Tornado fighter jet and the Cessna Citation business jet. The second is the Cascade reverser or cold stream reverser. The Cascade reverser or cold stream reverser has a more complex and specific design and is used on high-bypass turbofan engines. The Cascade reverser only deflects the bypass airflow generated by the fan, while the airflow from the engine core or turbine is not deflected. When the reverser is activated, the engine nacelle opens and the airflow generated by the fan is held back and deflected sideways. The airflow deflected by this Cascade reverser can be clearly observed when the aircraft lands on a wet or flooded runway. This type of reverser can be found on almost all commercial aircraft and large passenger aircraft, such as the Airbus A380 and Boeing 777. In terms of effectiveness, the use of a target reverser is more effective than a Cascade reverser. This is because a target reverser completely restrains and deflects the engine's airflow. A Cascade reverser, on the other hand, restrains and deflects only the fan airflow, while the exhaust airflow is allowed to flow backward. However, both types of reversers are still in use today. Some military aircraft, such as the Boeing C-17 Globemaster III and Lockheed C-5 Galaxy, have turbofan engines equipped with reverse thrust technology, capable of generating enormous reverse thrust. This means that by activating the thrust reverser on all four engines, the aircraft can move backward. However, this reverse thrust can only be used to a limited extent and in certain environments. This is different for turboprop aircraft. In turboprop engines, the thrust reverser is located on the propeller. Airflow reversal in a turboprop engine is achieved by changing the propeller's angle of attack, so that even though the propeller rotates in the same direction, the airflow is reversed forward. The thrust reverser on a turboprop aircraft can reverse airflow by up to 180 degrees, meaning that the thrust generated by the engine can be completely reversed forward. Furthermore, the thrust reverser on a turboprop aircraft allows the aircraft to land on all runway conditions, even sandy ones. However, not all turboprop aircraft can generate reverse thrust. Reverse thrust is only possible if the aircraft is equipped with a variable pitch propeller. Aircraft with fixed pitch propellers cannot generate reverse thrust. Although reverse thrust technology is very effective for slowing down and reducing the braking distance of an aircraft during landing, this technology has also been linked to several aircraft accidents, due to the thrust reverser casing not closing properly or opening suddenly. Therefore, modern aircraft are equipped with a locking system to keep the reverser closed while the aircraft is in flight. That concludes our discussion of reverse thrust technology in aircraft. If you have other interesting information on this topic, please share it in the comments section. See you in the next video.